K5 Desktop Board Inspector. The single most impressive feature of the K5 is an all-in-one body design that integrates the main unit, the PC, and monitor into one complete unit. The K5 requires no air supply, and it can start working only by supplying electricity from a plug. The compact design makes the K5 easy to move and install almost anywhere. Running tasks offline gives a wider range of freedom. Device is tilted to make the board installing task easier. Optical inspection head uses a linear motor, so operation is quiet and maintenance-free. Another great feature is an MMC function for controlling multiple units. If using multiple K5 units at the same time, this system can load all test results onto one master unit and then make pass-fail judgments on that master unit. This function allows making the actual pass-fail test judgments on just one unit, even in cases where one operator is running several K5 units. This means all pass-fail results can be integrated into one unit. Using the more highly developed C2 system allows a single inspector to handle a larger number of inspections so that pass-fail judgment can be standardized and operators don't have to be well-trained. Pass-fail judgment errors can be reduced and quick pass-fail decisions made by comparing inspection images with stored images of past boards. Incorporates the newly developed VADMIC inspection algorithm designed to make it easy to form data and make inspections even without special training. The VADMIC algorithm extracts image sections that differ from pre-stored images of past boards and then makes inspections both with and without those differing sections. The K5 first of all finds differences between the test board image and a pre-stored past board image. Sections different from the past board image are next extracted by filtering. Sections on the inspection image that differ from the past board image are colored and displayed. The board is in G at this point if different from the past board image. This difference extractor method also makes solder fillet and foreign object tests, as well as find character print errors. It also makes sophisticated inspections such as four-component model differences, the same as scanning by and optical character recognition. However, this method cannot make accurate decisions when sections differing from the past image contain both pass and fail components. In those cases, VADMIC divides the image into subgroups to find discrepancies on individual parts. An optional number of image subgroups can be set after checking the component size. This setting can be increased or decreased as needed, so the operator can freely make changes to match the component and screen size. Masks for individual components can of course also be set, but iPulse believes that even this is not enough. Here is an actual inspection image taken from an ordinary inspection unit. It extracts any discrepancy on every board regardless of conditions. So the inspection unit mistakenly detects many kinds of situations as errors due to light conditions or variations among components from different manufacturers. To eliminate this problem, VADMIC was given a learning function to meticulously reject all false information. The learning function on the K5 works as follows. Images judged a pass by the inspector are added to a collection of past board images. This entire collection of past board images, including those with differences, are used to eliminate false information. In other words, VADMIC keeps learning what cases are okay, and if that same case occurs later on, then the detected discrepancy is rejected as false information. On the K5, a laser displacement meter can also be set as an option to test for floating chips, floating BGA, floating leads, or polarity checks. Supplemental checks such as switch position checks and through-hole solder checks can also be made offline on sections where flaws are difficult to detect by optical techniques. The iPulse K5 Desktop Board Inspector has test performance rivaling that of full-spec models, yet also integrates the latest mechanisms into a compact one-piece body and vastly simplifies the job of forming data. The K5 brings a host of advantages to offline inspection tasks. The KX2 Hybrid Inspector. A main feature of the KX2 is that it can simultaneously make both X-ray and optical inspections along the same axis. The KX2 offers even greater inspection accuracy since it makes both X-ray and optical inspections along the same axis. Test time is virtually the same as the ordinary optical method, and this device has the speed needed for inline inspections. The optical inspection checks for missing components and position errors, etc. The X-ray inspection checks the solder fillet quantity and the polarity on terminals beneath the BGA. Making a composite of these two images yields accurate inspection results. This keeps losses, such as from test judgment errors, to an absolute minimum. By combining an auto-optical inspector unit with an X-ray inspector unit, we created a whole new type of inspector device incorporating the best points of each unit. That device is the KX2 Hybrid X-ray Optical Inspector. We recommend the K2 Optical Inspector, which is a compact and superb cost-performance machine where the optical method is needed. The unit cost is low enough to allow using multiple K2 units simultaneously for tasks ranging from print inspections to external visual checks before and after reflow. A 2 million pixel color camera and iPulse original dome lighting ensure a sharp screen image for the operator. The K2L is also available for handling even larger size boards.